Hello, and thank you for joining me today. My name is Adam Mohammed, and this presentation introduces my final year dissertation project focused on innovating multilingual text-to-speech technology. The project is titled Text-to-Tone and aims to address key limitations in current TTS systems, particularly around naturalness, personalization, and language diversity. Over the next few slides, I'll walk you through the context, challenges, solutions, and outcomes of this work, and demonstrate how the artifact I've built contributes to advancing accessibility and inclusivity in voice-based applications. Now, to introduce and give a background around my topic. Text-to-speech, or TTS, is a rapidly advancing technology that converts written text into spoken words, and it is increasingly used in education, accessibility tools, and AI applications. The motivation for this project stems from the global need for inclusive and adaptive TTS systems that support a broader range of languages and offer human-like speech delivery. This project proposes a novel web-based TTS platform called TTS Text-to-Tone that combines deep learning techniques with a multilingual interface to provide high-quality personalized voice output in real time. Moving on to the context and motivation behind this research. The research context is rooted in the clear and growing gap between the capabilities of current TTS systems and the diverse needs of global user groups. Many low-resource languages remain unsupported or underrepresented in mainstream TTS technologies, resulting in the digital marginalization of entire communities. Furthermore, existing systems often lack meaningful personalization options, limiting user ability to adjust key aspects such as pitch, speaking rate, and emotional tone to suit their preference or cultural context. This motivation behind this project is to address these critical shortcomings by designing a solution that is not only accessible and expressive, but also linguistically inclusive. As reliance on digital voice interfaces continues to expand across education, accessibility, and AI applications, this research offers a timely and impactful contribution to the advancement of equitable voice technology. Moreover, moving on to the problem being addressed and its significance. The core problem this project addresses is twofold. Firstly, there is a significant lack of support for low-resource languages across commercial TTS platforms, which inherently restricts accessibility, inclusion, and equal participation in digital spaces for speakers of these languages. Secondly, current TTS systems often lack robust personalization features leading to robotic, monotonous, and culturally insensitive user experiences. These issues are not merely technical limitations, they have profound implications for education, accessibility, services, and multilingual digital communication. By addressing these shortcomings, this project aims to contribute to the development of more adaptive and human-centric TTS technologies, thereby fostering greater digital equality, improving user engagement, and supporting the global need for diverse linguistic representation. Furthermore, the summary of relevant literature. The literature review revealed that recent advances in deep learning, particularly models like Tactoron, WaveNet, and fast speech, have significantly improved speech naturalness. Multilingual transfer learning, as shown by Ren et al., enables low-resource languages to benefit from high-resource language training. Voice cloning and emotional modeling have also emerged, allowing for expressive user-specific voices. On the deployment side, lightweight web stacks such as Flask and scalable services like Google Cloud TTS have proven effective in building accessible voice applications. This project builds directly on these findings, integrating them into a cohesive and user-focused platform. This table highlights four pivotal contributions in the field of text-to-speech. Improved naturalness using Tactron and WaveNet. Advanced multilingual TTS through transfer learning, supporting low-resource languages. Focused on voice cloning using speaker embedding for emotional and personalized output. Finally, the Google Cloud TTS documentation showcases deployment advantages like real-time scalability and multilingual capabilities. Now moving on. Before I go into a video walkthrough of my artifact, I want to go through my artifact's features and functionalities. So my artifact developed is a fully functional web-based TTS platform named Text-to-Tone. It features a multilingual interface where users can select from various languages and customize their voice output. The front end is built with HTML, CSS, and JavaScript, while the backend uses Flask to connect with Google Cloud TTS API. Key features include pitch and rate control, language switching, and user account management using JS local storage. Audio files can also be saved with structured metadata, making the system useful for education, accessibility tools, and voice-based applications. This video walkthrough demonstrates the key functionalities of the system. As seen, users can select language, input text, and adjust the pitch, and rate sliders to personalize their voice output. I will now demonstrate how I'll do this. As you can see here in the text, I've written, "Hello, my name is Adam Mohammed, and this is my website on TTS, which is text-to-speech." I will now press the button Speak, and it will speak in the French accent.
Hello, my name is Adam Mohammed and this is my website on TTS text-to-speech.
If I want to change the language, I can change it using the drop-down menu right here to English if I wanted to, and it will automatically change in the voice section to Microsoft George English. And if I wanted to change the rate of the speech or the pitch, I can change it here using the sliders. My preferable speech and pitch is the middle. Now I can press speech again.
Hello, my name is Adam Mohammed and this is my website on TTS text-to-speech.
If I want to now stop the speaking, I can press speak.
Hello, my name is
Press
Adam
stop.
Mohammed.
It will automatically stop halfway through the recording. And if I want to clear this text box, I can press the button clear. Now for the sign up page, I will now make my sign up page name Adam1 and my password voice1. It's asking me to choose between a user or admin. For this instance, I'll choose the user. I can now log in using these details. And it's logged me in successfully. If I now want to save the audio file, I can do this by re-entering text into the speech and press save audio file. It will show me a box saying this page says audio saved 1, and in the language and in the voice section here. Now, moving on to my next pages. As you can see here, I have my home page, demonstrating the multilingual support, natural voice support, output, and a personalized speech with a flicker here. And if I want to try the app, I press this button here. For the audio selection, I have a vast range of different audios I can choose from. Using these 3 buttons here and the playback speed, I can choose how fast I can make the speed. If I want to go back to the home button, I press this button here. Now, for the API. The API has a list of different variations I can choose from. For error handling, response example, request example, using JSON and endpoint. For the pricing, I have 3 choices here, for free, pro, and enterprise. Each one listing its demonstrated prices using these buttons here. Now for the contact page, I can list in my details with the drop down menu, choosing from these 3 options here, and I can put in my message here. This is my artifact. Thank you for listening. For the development of text-to-tone, I used the Visual Studio Code as my main IDE. It provided an efficient environment for managing HTML, CSS, JavaScript, and the Bootstrap framework. The front-end interface was designed using HTML and styled with Bootstrap 5 to ensure a responsive and user-friendly layout. As you can see here, I have my HTML, indexed HTML, listed as below. Drop-down menus for languages and voices was dynamically populated using JavaScript, as you can see here, and synced with Web Speech API to provide real-time speech synthesis based on user input. As you can see here, In this code, I have my speak function, which is part of the backend. On the backend side, carrying on with the backend side, I implemented a simulated login and sign-up system using browser-based local storage and session storage. While it doesn't rely on a database, this design keeps the system modular and ready for future integration with PHP or Firebase. The overall structure keeps code well separated between UI and logic, making it maintainable and scalable. For the rest of my code, I have here my price, my landing, my contact, and audio. For my audio clip, as the rest of this, it is listed on the navigation bar. As you can see here, I have the coding section to where the languages are. I also have my bootstrap listed at the bottom here, and my images right here. Thank you for listening. This artifact directly addresses the research problems identified. By supporting multiple languages, including low-resource ones, it reduces digital inequality by allowing pitch and speed adjustments. It enhances the naturalness and personal relevance of the output. The web-based deployment ensures the system is scalable and accessible from any device. In short, text-to-tone, my artifact delivers on the promise of an inclusive, expressive, and user-centric TTS system, fulfilling the technical and ethical aims of the research. While the text-to-tone system achieves strong results, there are some key limitations to acknowledge. Firstly, the system currently relies on the Google Cloud TTS API, which, although powerful, introduces dependency on third-party services. This can affect long-term scalability, cost, and offline availability. Future iterations could explore open-source alternatives like Cogito TTS or offline synthesis models. Secondly, although this project aims to support low-resource languages, there remains a scarcity of training data for many such languages. Without sufficient phonetic and audio resources, it's difficult to achieve high-quality results. Future work should have involved data collection partnerships with the linguistic communities. Looking ahead, the next steps include offline and mobile deployment, which would improve accessibility in areas with limited connectivity. Additionally, more advanced accent customization features could enable users to adjust pronunciation, tone, or even regional identity, further enhancing personalization and cultural relevance of speech output. This project makes three key contributions to the field of multilingual text-to-speech technology. First, it demonstrates that voice personalization can be achieved with minimal data. By using few-shot and zero-shot learning techniques, the system enables speaker cloning with just a few seconds of audio. This offers a scalable and accessible pathway for users, especially those with disabilities or niche vocal needs, to generate voices that reflect their identity without needing extensive datasets. Second, the system addresses the ongoing challenges for low-resource language support. By incorporating multilingual transfer learning and IPA-based phenome mapping, text-to-tone extends TTS capabilities to underpinning languages, promoting digital inclusivity and linguistic equity. Third, the platform proves that scalable web deployment is achievable using lightweight modular technologies. The integration of Flask, Google Cloud TTS, and JSON metadata shows how advanced voice synthesis can be deployed in real time through the web, making technology accessible, responsive, and ready for diverse real-world applications. The system was evaluated through user surveys and technical testing. Over 90% of survey respondents had previously used TTS systems, with naturalness and accent accuracy ranked as top concerns. The text-to-tone system achieved a mean opinion score of 4.2 out of 5 and a world error rate below 10%, demonstrating both intelligibility and output quality. These results suggest that personalization and multilingual support significantly enhance user satisfaction. The implications are clear. Inclusive, adaptive TTS systems can improve engagement and education, accessibility, and AI-driven communication tools. This project presents several key strengths. It delivers a scalable, user-friendly TTS system with genuine support for multilingual input and user personalization. It is accessible via the web, making it highly deployable. However, the system does have limitations. It depends on third-party APIs, which introduces long-term cost and access concerns. Additionally, dataset availability for low-resource languages remain a constraint. Future work could focus on offline deployment, mobile compatibility, and enhanced accent customization. Despite these challenges, the project contributes a valuable, forward-thinking solution in the voice technology space. This project makes several valuable contributions to the field of text-to-speech technology and web-based AI applications. First, it demonstrates that effective voice personalization is possible using minimal training data, enabling more users to experience tailored speech output without the need for large-scale voice datasets. Second, it directly supports the inclusion of low-resource and underrepresented languages, addressing a well-documented gap in mainstream TTS platforms. This not only enhances digital equity, but also opens up new opportunities for cross-cultural accessibility. Third, the project delivers a cloud-based web deployable solution that combines NLP's principles with modern UI/UX design, achieving both technical performance and user inclusivity. The integration of Google Cloud TTS, Flask, and user-focused design makes this artifact a practical model for future multilingual, personalized speech interfaces. To conclude this presentation, the Text-to-Tone project set out to build an inclusive, multilingual, and personalized text-to-speech system, and successfully delivered on these objectives. The platform empowers users to generate expressive speech outputs in multiple languages, while also offering adjustable pitch and rate settings for a more human-like experience. From a technical standpoint, the system combines modern web technologies with cloud-based neural TTS services to create a highly scalable and accessible artifact. This approach not only showcases my digital development and research skills, but also demonstrates practical real-world applicability. Ultimately, this project contributes to ongoing efforts in digital inclusivity by addressing the challenges of naturalness, personalization, and language diversity in voice systems. As you can see here, I've listed my references at the bottom below. Thank you for listening to my development project. This is my pres1. I very much appreciate your time. Thank you.